Question 10. Use Newton-Raphson iteration to find the turning point of the given function. So this is f of x. We want to find the turning point of f of x. In other words, we want to solve g prime x. Sorry, we want to solve f prime x is equal to 0. So f prime x is equal to 0. In other words, we want to find the solutions to this equation. Now, in your Newton's formula, you have xr plus 1 is equal to xr minus f of xr over f prime xr. But in this case, let us say let g of x equal to f prime x. So what we can say is, therefore, g of x is now equal to, remember it's f prime x, g of x is equal to find the derivative of e to the power 0.5x, it will be 0.5 e to the power 0.5x minus, to find the derivative of ln falls away, we take 2x, we find the 2x goes to the denominator, ln of the argument, which is 2x, and the derivative of goes on top, which is 2. So in general, if we have y equals ln f of x, the formula is y prime is equal to f prime x over f of x. Ln falls away. So the derivative, so what we're getting is 0.5 e to the power 0.5x minus 1 over x. I can write it as x to the power minus 1. Now, see, we want to solve this here equal to 0. So if you have to solve this g of x, we want to equate this to 0. So we have this equation, which is equated to 0, which is g of x equal to 0. Remember, in the formula, we need, so let me modify this. So in the formula, we're converting the f prime x to, we are converting this f prime x to g. So therefore, we are not going to use this formula directly. So what we're actually finding is, what we want to use is xr plus 1 is equal to xr minus g of x r over g prime xr. Now we know what g of xr is. So g of x is equal to 0.5 e to the power 0.5x minus x to the power minus 1. So g prime x is equal to 0.5 times 0.5 is 0.25 e to the power 0.5x plus minus times minus is plus x to the power minus 2. Therefore, we will use this approximation. X r plus 1 is equal to xr minus, so g of x, which is 0.5 e to the power 0.5 xr. Remember, x in place of x, we just substitute xr for the formula, minus xr to the power minus 1 all over 0.25 e to the power 0.5 xr plus xr to the power minus 2. Perfect. Now, when the value of x naught, we said use initial approximation of x is equal to 2. So when r is equal to 0, we're saying x naught is equal to 2. Now x naught is equal to 2, that's our starting point. What is x1 equal to? We're going to take 2 and substitute in the place of xr. So your first formula should actually be, in the place of xr, we substitute 2. So let me pull out my calculator and show you what we are talking about. So what I suggest for Newton's method is always, if they give you a starting value, you start with, is just say 2 equals, right? Put your calculator on. Now instead of saying xr, just say answer. Answer, subtract 0.5 shift e to the power 0.5 answer minus answer to the power minus 1 over 0.5 shift e to the power 0.5 answer. Sorry, it should be 0.25 here. 0.25 e to the power 0.5 answer plus answer to the power minus 2 answer to the power negative 2. Right, we are going to press equals. Let's see if our function is fine. Right, we're going to press equals. So we will get 1 point. We will get our first value as 1 point, this entire thing here, 1 point. Okay, so we want to 5 decimal places, not the full. So 1.07577, 1.07577. Now if you substitute this into the next one, we will get x2, right? x2 into, so in other words, r was 0, r is equal to, now in this case, not there, r is 0 here. Now r is equal to 1. So we're recovering x2 by substituting x1 in here, right? So all I'm going to do is just press answer again. It's a cheat method, right? Oh, sorry, not answer. Let's go back. All right. Delete. Supposed to be pressing equals, right? I'm going to press equals again. I'm going to get 1.13255. 1.13255. We want to round off to 5 decimal places. Then press equals again. We're getting 1,134 x3, 1,13429. Okay, so 285, so 29, and then press equals again. We will get 1.13429, so x4. So x4 is 1.13429. We stop because we wanted to 5 decimal places. We stop here, and then we can say this implies my solution is x is equal to 1,1343. Round off to 4 decimal place. Or you can leave the answer as 1.13429. That is your final answer. Now, we wanted to find the turning point, right? So we wanted to find the turning point of this function. So we found a solution to g of x. So we have a solution to g of x. Now, x is equal to 1,134 is a solution to g of x. Now, if you want to find the turning point, remember we found a critical value. This x value is a critical value, right? To get the y value, we need to say f. We always need to take this and substitute into the original. So f of 1,1343, and we are going to get, by substituting 1.1343 into my original function, which is the f graph. So it is, let's see what it was. So we're going to substitute back into our calculator. So shift e to the power 0.5 times 0.5 times 1.1343 minus ln 2 times 1.1343, and we press equals, we get the answer 0.994, 0.9441. So I've entered this f of 1,1343 in the calculator, in other words in the original function, e to the power 0.5 times 1.1343 minus ln 2 times 1343, 2 times 1 point. Right, so I've got an answer which is 0.9441, which is 0.9441. Therefore, question asked us for the turning point of the given function. Therefore, TP is equal to 1,1343, right, which is the x value, and 0,9441, which is the y value, y value, right? And that should be a solution. 1,1343, let us just go and observe, just somewhere around here, 1.1343, and the y point is just below 1. So turning point is somewhere around there, very close to 1. That's what it looks like, observed from the graph. You can't go way off. Now guys, let us just get back to this question here. Since they gave us what value to use, assuming that they did not give us a value, we can use the intermediate value theorem to approximate between which 2 points the turning point lies. So you can use 1 and 2. If you choose the value 1, what you will find is by IVT, right, intermediate, I'm just looking at, if they didn't give us this, you can say g of 1, if you get, just say if you find g of 1 and if you get an answer which is less than 0 and g of 2 we get greater than 0, it must satisfy 1 greater than 0, 1 less than 0, just assuming that g of 1 is less than 0 and g of 2 is greater than 0. Then the best point to choose is the midpoint of 1 and 2. So you can just choose x value as 1,5. So a better starting value should have been 1,5. But anyway, since they gave us x is equal to minimize the iteration, a better starting point should have been x is equal to 1,5. But since they gave us x is equal to 2, no problem. We can use the Newton's method to get our answer. So our solution ended up being 1,1343 and 0,9441, which is the turning point of f of x.